today we are going to discuss that magnetism is a relativistic phenomena. That means magnetism differs from person to person or observer to observer. Means for some observer it appeared to be an electric field, or for other observers it may be appear as a magnetic field. Okay, so we will discuss the whole matter. So let's get started. Before starting our main topic, we have to discuss the length contraction. It is a relativistic phenomena. Okay, so we will discuss what is it. I have two frames. One is S frame and one is S prime frame, and S prime frame is moving with a constant velocity v with respect to S frame. We will call S frame as a rest frame and S prime frame as a moving frame. Okay, now suppose I have a wire. Okay, the length in the S frame or rest frame, let L naught. The length of the wire in the S frame, let L naught. So length of the wire in S frame, the length of the wire in S frame we let L naught. Okay, now the length of the wire in S prime frame, what will be that? It will be L. Okay, now here comes relativity. Always moving length becomes shorter than the rest length. From Einstein's special theory of relativity, we can prove that L equals to L naught under root 1 minus v square by c square, where c is the speed of flight in vacuum. Okay, so here one thing is that moving length always shorter than rest length. Okay, why moving length shorter? Here L is the moving length and L naught is the rest length. Now under root 1 minus v square by c square, it is less than 1. So anything less than 1 is a small quantity than this. So L is less than L naught. Okay, now we will come to our main topic. Now I am taking a case and we analyze the case in two frames, S frame and S prime frame. Okay, so let's start. I have a wire. Okay, I have a wire, suppose a long wire, and I have here cations and free electrons. Okay, here I have cations and free electrons. I represent the cations as plus and free electrons as negative sign. Okay, now in S frame the cations are at rest. These cations at rest, and the electrons are moving with a velocity v in this direction. Okay, so what is it? The positive charges in S frame is at rest and the negative charges are moving with a constant velocity v. Okay, now here let lambda plus is the linear charge density of positive charges. Okay, I am taking lambda plus as lambda naught and lambda minus is negative lambda naught. That means linear charge density of positive charges and linear charge densities of negative charges are equal. Okay, numerical value is equal, so that lambda plus lambda minus is 0. That means the wire is neutral. Okay, so S frame I have got that the wire is neutral. Okay, now if I analyze the case in S prime frame, the same case, now I am looking this wire from S prime frame. So what will be that? I have that wire, here is cations and I have free electrons. Okay, now the frame is moving with a constant velocity v. So here will be the electrons will be at rest. Free electrons will be at rest and the cations will move this direction with a constant velocity v. Okay, now I am looking at the wire in a moving frame, from a moving frame. So here will be the we will apply the concept of length contraction. Okay, now if I measure the wire from S frame, okay, if I measure the wire from S frame, let the length of the wire is L naught, and if I measure the length from S prime frame, let this will be L. Now we know linear charge density lambda is actually Q by L, total charge by length. Now here the length will be shorter but the charge will remain same. Look at here carefully that L naught is greater than L, means I am looking from a moving frame, so L will be smaller than L naught, means this length will be shorter than this length. That means, but the Q remains same. Because charge will not change, there will be no relativistic effect on charge but on the L. So here L is shorter but charge remains same. So what will be that? So lambda plus will be increased. And this will be lambda naught divided by square root 1 minus v square by c square. Okay, now what will be the case for negative charges? Now negative charges in the S frame is moving but in S prime frame is at rest. So here will be the opposite event is happening here. means for the negative charges it is the S prime frame and it is the S frame, we may suppose that. So the negative charge density will less than the S prime. One minus V square by C square. So if I do here lambda plus lambda minus, it will not 0. That means the wire is charged here. The wire is charged here, but here is neutral. So same wire, if we look from S frame, it is neutral. If we look at this wire from S prime frame, it is charged, and lambda plus is greater than lambda minus, so it is positively charged. Okay, now if there is a charge q, I erase this. Now there is a charge q from at a distance, from a certain distance from the wire. Okay, now look at S prime. So the wire is positively charged here, positively charged. Hence the wire is positively charged, there will be a electric field, there will be a electric field, and the force will be QE on the charge q. But here is the wire is neutral, so there will be no force on q due to electric field. So what is it? Here will be also force, the same force, but the observer in S frame will not see it in terms of electric field. So here is need another field. Okay, here is need another field, and here will be act magnetic field. So magnetic field is the relativistic phenomena of electric field. So magnetic field is a relativistic phenomena of electric field. That means electric field and magnetic field are the two sides of a same coin. One observer may experience that it is an electric field, and one observer may feel that it is a magnetic field. Okay, so this is our today's topic. Thank you.